In this video, we'll talk about how to use Python in OTLs. Now, OTLs are one of the areas of Houdini where Python becomes extremely powerful, and I use Python in almost all the OTLs that I create, unless they're very, very simple OTLs. The fact of the matter is that you can use Python to extend your capabilities with OTLs a lot. Now, the first and most simplest thing that I'd like to talk about is how to create callbacks with Python in OTLs. So if we take our particle controller node here and right click and go to type properties, the way that we create a callback, if we go to the parameters tab, is to first create a parameter. So if we make a button, we can call this callback test. And then the way that we create a callback is with this callback script. So what's a callback? Basically, a callback is a simple script that is run every time the button is activated. And this works with any parameter, so it's not just buttons. So in the case of buttons, the callback runs whenever you click the button. In the case of, say, a string parameter, every time you change the string and then hit enter, the callback will get run. Okay, so how do we do this? Well, by default, you can see this little H here next to the callback script field. And that's saying that this callback is going to be an H script, which is not what we want. So if we pull that down, we can just change it to Python. So a callback script is going to get run like any other script in Houdini. So if we wanted to, we could just put something like who.ui.display message, and then, yay, it is a callback. And notice that I'm avoiding using the single quote here. So I put it is. And now if we hit apply, and if we click this button, we get our nice dialog. So say that we wanted to do something a little bit more complicated in here than simply displaying a dialog. Say we wanted to color the node purple and then display a dialog confirming that we had successfully colored the node purple. Well, there are a couple of different approaches that we could take. Probably the best approach is to, if we just delete this, head over here to the scripts tab. So this tab allows us to add scripts to specific parts of our OTL. And the way that we tell it which part of the OTL to put the script in is this event handler field here. So if we pull down this menu, there's a bunch of different options in here. The one that we're after right now is Python module, but later we'll be taking a look at some of these other events. So what do I mean by events? Well, basically these scripts get run when certain things happen to your OTL. So for example, if we use the onCreated event, then that would actually run a Python script when someone creates our OTL. And then there are a bunch of other ones. We can have it when it updates. I think this is when the node's definition is updated. You can have a script run when someone deletes the node, when someone changes the input or the name, etc. But right now what we're interested in is the Python module. So if we click on that one, it adds this Python module script here. So the way this works is you'll have your list of scripts over here on the left, and then you can type into here to have your actual scripts. So what this Python module is for putting general Python code into your OTL, which is what we want to do now. So this can be things like callbacks, it can be things like general functions that are just related to your OTL. You can import things here that you intend to use later, all kinds of things that you can do here. So let's just go ahead and define a function that will be our callback. So if you remember how we define functions in Python, we use def, and then a function name, say callback test, open parentheses, And then here is where we would define some arguments, but we're not going to do that yet. So let's close parentheses, and then single colon. Not a semicolon, just a regular colon. And then we hit enter and hit tab again. And now anything that's tab indented here is going to be part of the body of this function, meaning that when we call this function, this code is going to get run. Okay, so let's just have it display the dialog real fast. So if we do who.ui.display message, and we say, yay, a callback again. This one is coming from the Python module. Okay. Now if we hit apply, you'll note that this isn't really any more complicated than what we were doing before, but we'll make something a little bit more complex in a second. So now how do we access this? Because this is just in a Python module and we can't import this. Well, Houdini has a special function that returns it on who.node. So if we go back to our parameters pane here, so in our callback script, what we can do is say who.pwd .hda module .callback test, open close parentheses. And if we hit enter and hit apply, now when we hit our callback test button, we get our nice dialog. Okay, so how does this work? Well, who.pwd is a function in the who module, and that returns the current node. So you can kind of think of it as your working node. Now notice that this is not necessarily the node that this is actually being called from, which is a bit annoying, and we'll see how to get around this later. Most often though, this is the node that the function is being called from. So in this case, it'll be this node if we click the button on this node. HDA module is a function on who.node, which you'll notice is what pwd returned, that returns the Python module for that node. In this case, it'll be this Python module here. So now that we have that module, we can just call our callback test. Okay, so what if we want to have it color the node first? Well, we can just use who.pwd over here also. So if we say who node equals who.pwd, and then we say who node dot set color, who.color, and then don't forget your square brackets. Then I'll just say something like 0.20, 0.6. And then we'll just change the text in the display message function. And we'll say something like successfully colored the node purple. And hit apply. So now if we hit callback test, we get a syntax error. It doesn't like something about my, okay. It doesn't like something about my display message. Oh, okay, so this is a little bit confusing. So you'll notice that it was giving me this line, the display message line. But if you look really carefully, there's actually not a syntax error here. This is because Python will often, it'll hit an error on a line and then give you the error for the next line. So where the actual error is here is I forgot, you'll notice that it's highlighting this parenthesis here. I forgot a parenthesis here. So the reason why it's giving me the error on this line is that it thinks that I meant for this line to be part of this line. So it's like, how do you have a tab indent here? That doesn't make any sense. So now if we hit apply, and we hit callback test, it says successfully colored the node purple, and in fact it did. Okay, so we said earlier that using who.pwd for this is a little bit unreliable, and there are a couple of different reasons for that. The first reason is that in here we're defining what our current node is by who.pwd inside of our function. So watch what happens if I, for example, go to make a new shelf tool. Let's go here. And then I say, let's just call this experiments. And apply. And then if I just drag this node into here and say who node equal that. So the cool thing about HDA modules is that you can access them from anywhere, so long as you have an instance of the node or a type of the node that has the HDA module that you're trying to access. So in this case we have the instance of the node, so I can just say who node.hda module. But now if I try to say callback test, what we would expect is for this to just run the same way as if I'd called this from this node. But if we hit apply, and then we grab this guy and color him back to gray, and then I just hit this experiment button, well, it brings up the dialog, but you'll notice it didn't color the node. And the reason for that is if we say print who.pwd here, hit apply, and then click the button, hit OK. Where did it put my console? Here it is. Okay, so that was the print statement. Here, let me just close this down. Okay, there's our console. You notice it's just giving me a slash here. So this is because who.pwd is used for other things in Houdini than just getting the current node. You can also, in the Python shell, use who.cd to change the current working directory. And that current working directory is sort of the default one that exists outside of OTLs and such. So the problem with using who.pwd here is that it could end up getting evaluated to pretty much anything, depending on who's calling this function. Now you might be thinking, well, I have this function in here and I know it's only going to be called from inside this OTL, so it's okay for me to just use who.pwd for that. And you might be right that it's more or less safe in that case, although I have had random cases come up where that did end up breaking. But it's probably best to get into the habit of making it so that you can call a function from outside the OTL, because you never really know what you're going to want to use a function for. So how do we get around this instead of using who.pwd for this? Well, the simplest way is just to delete this line, and then pass in the node as an argument to the function. So we have who node here, and now whenever we call that, we have to give it the node that we're calling it from as the first argument. And really, I make a habit of just doing this anytime I need to access the current node from inside the body of the function, because it just makes things so much easier later. Okay, so if we hit apply here, and then we change our shelf tool, if we delete this print line, and then put who node here, and hit apply. Now if we hit experiment, it does indeed color the node purple. Now notice that we've broken our button saying type error. It needs one argument. And that's because we added a required argument in here, and the callback that's calling this function isn't actually passing in this argument. So if we go back over here to the parameters tab, we can fix that real fast. Now we could just put who.pwd here, but if you're like me, you've already started to get an idea of how unreliable this can really be. So let's look at some alternatives. So let's just go ahead and clear this real fast, and then say print kwargs. You might be going, whoa, what is kwargs? I didn't define that. What is that? Where is that coming from? This is actually a keyword that Houdini defines in certain places. So certain text fields where you can enter scripts in Houdini, there is this kwargs dictionary that exists for free. Okay, so if we hit apply, and we click on callback test, here's a list of all the information that we get from kwargs from the parameter callback field. Now notice that kwargs will change its contents depending on where you are in Houdini, which is a little bit confusing, but it makes sense because if you use it in a shelf tool, then it needs to give you different information. There is no node, for example. Okay, so this is what we're after right here, is the node. This is something that will always be the node that we're calling this callback from. You might notice that there are a couple of other interesting things in here, like script multiparm index, which is it's if you're in a multiparm block, it's the index that you are currently. If you don't know what a multiparm block is, don't worry about it. Parm is the parm that's running the callback, so that's kind of cool. And then parm name is just the name of that, so that you don't have to do this guy dot name. Alright, so if we hit clear and close, what we can do is just say kwargs node dot. And then this is now what we were using who.pwd for before, only it's a lot more reliable. Now if we say HDA module dot callback test, and then we pass in kwargs node as our argument, and then we hit apply, and then we go to scripts. Yeah, that should work. So let's just go ahead and color this gray again, and then hit our callback test button, and yes, it still works. Okay, so the last thing I want to take a look at really quickly, if we just cancel this, is the other events in this list. We won't have time to go over all of them, but I think most of them are pretty intuitive. Let's just take a look at onCreated first. So this script will run anytime an instance of the node is created. So if we change edit as from hscript to Python, we can just say something like print blorg and hit apply. And now when we put down an instance of the particle controller, we get this blorg. There are several other events that we can have in here. Say on input changed, we could say print font. Notice that it's making this red because I forgot to change edit as to Python. Now it's good. Apply. Now when we change this, it says font. So that's all pretty cool. Now notice that in these modules, we also have access to kwargs, so we could say print kwargs here. And then say particle controller. And this is the kwargs dict that we get out of the uncreated module. Now notice that these are actually different from what we were getting from the callback. As I said before, it gives you different things for different places. In this case, we only have the type of the node and the node itself. But that's plenty, really, for most of the things that you want to do in these. So if you wanted to access the Python module from in here, you could say kwargs node.hda module.callback test kwargs node. Same thing that we did with our callback. Hit apply. And now whenever I put it down, it runs that function the same way that the callback does.